Hey guys, so you guys are joining me in my basement right now, and this is the quick review of the angled pairs unit, and following this will be a quick video on slope. So remember, angled pairs start off with vertical angles. They are formed by two opposite rays, so 1 and 3 are vertical, 2 and 4 are vertical, and they're also equal to each other. So that means whatever 1 is, 3 is, whatever 2 is, 4 is. Okay? And remember, to find the one next to it, I would subtract from 180 degrees. So 180 minus 83 comes out to be 97. Y is going to be the same. Z is going to be 97 because it's vertical to X. When I'm solving them, something like this, all I do is I set them equal to each other, and then I solve. Linear pairs are angles that form a line. Okay, they're right next to each other. It means they add up to 180 or are supplementary. So again, that goes back to our previous equations. If 1 is 55, 2 has to be 125 because it has to add up to 180. To solve problems like this, I would add the two equations and set them equal to 180 degrees. This is when they are right next to each other and they form that line. Okay, they always add up to 180. The other things are when we have multiple lines and it's cut by a transversal. So remember the angles like 4, 3, 5, 6, those are on the interior. Everything else is on the exterior. Okay. We have corresponding angles, which are in the same relative position, but they're on different lines. Okay. We have alternate interior angles, which are inside those parallel lines, but on opposite sides of the transversal. Alternate exterior angles, they're on opposite sides of the transversal, but outside the two parallel lines. And then we have same side interior angles. They're on the same side of the transversal, but inside the two lines. And those are the only ones that are supplementary. Those are the ones that add up to 180 degrees. So, corresponding angles, those are congruent. Alternate interior angles, those are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. So if you have any corresponding alternate interior or alternate exterior angles, if there's algebra, you just set them equal to each other. For same side interior angles, you add them together and set them equal to 180 degrees. For this, okay, I'm telling you A is 57 degrees. So if A is 57, I can subtract from 180 degrees and get 123. I then can do my verticals, okay, and then use my corresponding angles or my alternate interior angles to make the jumps to all the rest of those angles. Okay. Now, remember, these are congruent and these are supplementary. Okay, those are key to when you're setting up an equation. If they're congruent to each other, set them equal. If they're supplementary, add the two equations and set them equal to 180 degrees. Proving lines parallel is key, knowing that which ones are congruent and which ones aren't. So we use the same things, okay, that we know. So in this case, and I think I've shown you this before, it's asking you to prove the lines parallel. We don't know, but we do know that angle 1 and angle 2 are alternate exterior angles. So we write this sentence. The angles are alternate exterior angles and congruent, so the lines are parallel. And I can repeat this with alternate interior angles. Okay, these are alternate interior angles and they're congruent, they're equal, so the lines are parallel. It's all about stating what angle they are, if they're congruent, and if they are, then the lines are parallel. The only trick comes with these types of angles where they're same side interior angles. Same side interior angles have to add up to 180 degrees. So they are supplementary, and if they are supplementary, then the lines are parallel. But you have to write it out. And the trick comes from questions like this. Well, those do add up to 180 degrees, but those two angles are only in one line. They don't have anything to do with P on the bottom. Those form a linear pair, and linear pair angles have nothing to do with lines parallel. So we just say they're linear pair angles, which do not prove lines parallel. We don't know if those lines are parallel or not, because linear pair angles we don't have enough information. Okay? Hey guys, so this is the quick review of slope. So slope, remember, there's two ways of doing it. Rise over run, or y2 minus y1 over x2 minus x1. So that happens, rise over run happens when you have a graph and you have this line going through it. You choose 2 points, they could be anywhere, and you just count up 1, 2, 3, 4 over 1, 2, 3, 4, 5. So let's say it's 4 over 5. That's my slope. Now I always read it left to right, and if I go down first, then this number is negative. This, I find the slope between 2 points. So let's say 1, 2, and negative 3, 4. I would do 4 minus 2 over negative 3 minus 1. I would get 2 over negative 4, and then have to reduce down to negative 1/2. That's my slope. Remember, I always have to reduce. If it's a negative 2 over a negative 4, that comes out to be a positive. If one of these is negative, the whole fraction's negative, that sort of thing. The second thing about slope is parallel versus perpendicular. Parallel means they have the same slope. So I would have, let's say, 4 points, and if this is slope of 1/2, 1/2, these are the same. Okay, that means that the lines are parallel. Perpendicular means opposite reciprocals. So if one slope is 2/3, the other slope is negative 3/2. So I flip it and change the sign. If it's 4, I magically put a 1 under it, and I would do it's negative 1 over 4. So that's perpendicular. So you'll always be asked questions dealing with this when you have something like determine if AB is parallel, perpendicular, or neither to DC. So they would give you like 4 points, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just as a quick example. So all I would do is split it up. I would find, okay, what's the slope between here? Well, that's 5 minus 3 over 4 minus 2. That's 2 over 2, that's 1. Okay, 9 minus 7 over 8 minus 6. Okay, that's 2 over 2, that's 1. Okay, these are the same, so they're parallel. Let's say they come out to be opposite reciprocals. Well, that would be perpendicular. If they don't fit either category, then it's neither. Okay? The third time you use it, these slopes, is when you're writing the equation in y equals mx plus b form. There's 3 types of equations that we can solve stuff for. Okay? Let's say write the equation with m being 2 and the y-intercept being -4. Well, that's the quick one. M is 2. The y-intercept is another way for saying b. So I would say y equals 2x minus 4. The trick comes when I say, okay, the m is -2, and it passes through 6, 8. Okay? I'm just making these up. So I would take my slope and I plug it in, -2x plus b, and then I take these and I plug it in for x and y. So I would then do 8 equals -2 times 6 plus b. So -2 times 6 is -12. Add 12 to both sides. B equals 20. So now my equation is y equals -2x plus 20. Okay? And then I ask you other problems, like passes through, I'll use 6, 8 still, and is parallel to y equals 2x plus 4. Okay? All I do is parallel means it's the same slope. So m here is 2. I keep it the same. 2x plus b. I don't care about this 4. I cross it out. And then I just use my points that I did the same time. I plug it in. 8 equals 2 times 6 plus b. I solve. B ends up being -4 in this case. So my new equation is this. The biggest thing is that I ignore the b that was there. Okay? And the only thing that changes with parallel, okay, is when I say perpendicular. To, let's say y equals -2, I'll make it 2x plus 4, that same equation. Well, perpendicular means opposite reciprocals. Again, I ignore this. I don't care about that b. I only care about this 2. This 2 is really 2 over 1. We usually don't write it. We want the opposite reciprocal of it. So that's going to be 1 over 2 negative. So that's going to be -1/2. So now I take that and I plug that into my new equation that I'm creating. I take my points, I plug those in. Just so you don't freak out, 1/2 times 6, half of 6 is -3. I add 3 on both sides, I get 11. My new equation is that y equals -1/2 x plus 11. So that's how I write the equation. That's parallel versus perpendicular slopes. Okay? The other application of parallel lines, or the slope, is if it's proving if it's a parallelogram or not. So if it's a parallelogram, okay, you're again going to be given, okay, the same thing. You're going to be given 4 points, okay, and it says, is this a parallelogram? What you have to find out is you have to find the slope between each one of these points. So you have to find the slope between A and B, you have to find the slope between B and C, C and D, and D and A. Okay? And so we know this was 1, we know this was 1 from the previous equation. Okay, this is still going to be 1, okay, and this is going to be 1. That's not really a big deal. As long as these two match up, these are the same, and these two are the same, because being the same means that they're parallel, that would mean that this is a parallelogram because opposite sides are parallel to each other. If this had turned out to be a -1, okay, or let's say the slope between this is 2, this slope is 3, slope between this is -1/3, slope between this is 3, and this is -1/3. These are still parallel, okay, so it's a parallelogram, yes, but it has an added thing of being opposite reciprocals to each other, each side. So that added thing means it's a rectangle also. So it can be a parallelogram and a rectangle at the same time. But a rectangle has to have opposite reciprocals because that means that the corners are meeting at 90-degree angles. Okay? And that's the quick review of angle pairs with slope.